welcome back. Let's see, it would be week 3 at this point. So, welcome back to computer science. Or welcome back to an intro to computer science at the Trans Academy. I'm Lucia, or Random. Apologies for the confusion on this. Daylight savings time threw a little monkey wrench in the schedule for this. So, let me go back to the first slide real quick. Okay, so what we're going to be covering today is loops and conditionals, which would be how you control how many times a piece of code is going to be run, as well as when you know if the code is complete or when you want it to execute a specific condition or a specific block of code in the event certain conditions are true. Such as if x equals 1, run this code. So this is actually where we start getting into logic. So a if-then conditional, and I did realize when we were going through this that we do not have match cases currently in here. They will be on the official slides that are handed out later if anyone wants to see an example for that. So what's a conditional? So simply put, a conditional allows us to perform different tasks depending on a Boolean check. What's a Boolean check? A Boolean check is a variable that contains a value of true or false. So, true being, for example, if this was true. So, if this was true, let me go over to here real quick. So, in the event this is true, right? Then this block of code will execute. In the event it's not, this block of code will execute. Wow, my full body tracking is not doing me any favors today. All right. So let me jump to the next slide real quick. So Boolean check. Boolean is simply true or false. In the case of Python, these are capitalized. The data type for this is bool. So, for example, you have type string, type int, and type float that were covered in previous lessons. Here we have a type simply referred to as bool or Boolean. So, in this case, we're using the Boolean to demonstrate a check for which branch of the execution we want. So, if true, we'll print true. If false, we'll print false. Also, yeah, okay, let me go to the next one. So, what exactly can be Boolean checked? So, there's a few different, and I'm going to use the terminology here on operators, which are the symbols and whatnot that were defined here, right? So, double equals, for example, being that this is exactly equal, or this is equal to this value. A less than, which is this right here, will equate to true in the event that the value on the left is less than the value on the right. Greater than, very similar logic. However, greater than's a little strange on this, right? So if I was equal to it, technically I'm not greater than, so this would return false. If this was, say, 1.1, then this would be true. Okay. If you wanted to do a check for greater than or equal to, you have greater than symbol and the equal sign directly after it. There is also an equivalent to this for less than, which is the less than symbol with the equal sign directly after it. Okay. So, show an example on this real quick. We have set the value of... Actually, let me slow down for a second here. Does anyone have any questions so far on any of this? Yeah, go for it. Can you repeat that? I apologize, I didn't hear you.
I'm guessing the else if and if statements are basically similar to what you would get in Java, correct?
Correct. Yep, yep, correct.
Principle?
Yep, exactly. The only thing that'll really catch you up in the case of Python is that they're a little bit strange on how they handle booleans. Because in most languages, it's a lowercase true, right? But Python's weird, and they've insisted on making it uppercase, which usually is not going to throw you for a loop unless you need to explicitly write it in the code, in which case it's going to look it's something that's very easy to forget. So, like for example here, right? So is true with a capital T. In most languages, this is lowercase. Yeah, I don't know why they did that. I'm sure there was some design decision for it when the language was developed, but Python decided to be a little different on this one. That's a good question. Yeah, it's very similar.
Thank you.
Yep, anytime. Does one also work? So depends on the, okay, so which one are you referring and which part are you referring to? Do you mean by in like a comparison or do you mean by if one print x? Does this print? If I get this wrong, someone's going to correct me on it later. But yeah, let me think on how to phrase this. So I get what you're saying on this. In some cases, you can have a boolean that will eval. So 1 and 0 do equate to conditionals. So for example, if you were to pass them into a boolean function, they would return true or false, depending on the respect. This is reversed. That makes sense. Okay, that makes sense. Yeah. So yeah, while we're on, I apologize. Okay, so maybe I should write over here on this. So,
You can use
oh,
the pen in the player now.
will it work?
Let's hope. Fingers crossed.
I don't think it likes me.
Ah, boo. You just have to write more, bigger.
Ah, fair enough.
It probably would have to be reloaded.
Correct.
Ah, well.
It happens. It'll work next week, I'm sure. I have faith. There is so I guess just for fun, there is a function in Python which is just called bool. How small is this for everyone? This is really tiny, isn't it?
It's
Yeah,
split
I can
for
like
us.
I can barely see it unless I'm like, and it's inverted as well.
Darn it. All right. Is there a good example here I can work with on this? There's not a good example I can manipulate on this, so I guess I'm just going to jump over here and I'm going to draw really, really big. Okay, so there is a function which is just called bool in Python. And this function functions very similar to int or float. Okay, that's weird. Why is that drawing now? Hold up, wait, what? Hey, it works now. Okay, so I hope this works well. Okay, so I'm gonna find a big blank slide that I can write this on. Something with a lot of empty space. We'll use this one. So, hitting me. All right. Okay, so there's a function called bool. This is very large. And it will take an argument very similar to how int is handled. And this argument can be a number. So let's say hypothetically I passed it 1. I would expect it to return the correct Boolean value to me, which I want to say, let me double check my math on this very quickly before I actually run my mouth, because I do not want to mislead everyone. You know what? That's fine. I'm 99% sure this is correct. So that should be a true, if memory serves. In the event this was a 0, in the event that was a 0 value, erase u, and erase u. Yep, that's correct. And that would return false. Let me Is that? Oh, I see. Okay. Okay, cool. I think I figured it out now. I see someone typing, but does that answer your question?
I was having major keyboard layout issues. I'm sorry. I was typing for like 10
No,
minutes.
you're fine. You're
I just wanted
fine.
to say, yeah, with bool, if it's anything but 0, it's going to be true.
Yep.
So, yeah. And I'm probably late, but.
No, you hit the nail right on the head. Yeah.
Alright.
Most of the time you're gonna just set it to the Boolean value, and you're not gonna be dealing with like, is it 0 or is it 1 to convert it over correctly. But
in Python, you can do one double equals true. True and one are reversible.
Yes,
zero
you
and
can. Yep. That also works in JavaScript, and I think most languages that are duck typed it works in.
Yeah.
Yeah. Also a great way to introduce a bug if you're doing something, if you're doing it with, like, say, user input.
Ooh. Ooh, yeah.
Yeah.
Oh, yeah.
True, though I thought C++ would yell at you first on the typing before you did it. Ah, why is my... I am
I've seen
having
people at the top.
tons of issues today.
I've seen people at the top of C++ files just do define all caps true as 1. That's usually the way around it. Well,
True.
usually. Practical way around it.
It would yell at you for missing the semicolon on the next line. Yeah, valid point. Alright. Let me go back here real quick to where we were at. So we're at Boolean check. We got through here. Kind of covered this a little bit, but using user input as an example, let's say using user input as an example, let's say that I take wow, okay. Okay, so using the user input as an example, right? So let's say I take a value, and it's going to return, and I'm going to get a value of, oh, let's say they give me 1, right? Okay, so we're going to pass, so input is going to receive that value, and it's then going to be passed into the int function, right? The int function is then going to set x to equal 1, which, going through here, if x is less than 0, okay, well, 1 is not less than 0, so this would not print in that scenario. If, and we have an elif here, so if x equals 0, then we would print 0. That's not the case. However, because we have 1, it would be x equals 1, and it's going to print single. Alright. In the event we were to put 0 in here, it would skip this, end up printing 0, because equals to 0. If it were a negative value, let's say we had -2, we would end up executing the print negative change to 0. And if we received more than that, we would end up executing the else block at the bottom. Thank you for fixing the marker, by the way. Alright. Yeah, so before we go on to loops, does that all make sense to everyone? Alright. Let's continue on. Okay, so what is a loop? A loop provides the capability to perform a set of operations over and over again. So, let's say, for example, I have a condition I want to continue to execute. We're just going to continue to loop around it. It's also one of the main ways on how you avoid repeating yourself within the code. So, for example, this. We probably don't want to have 100 print statements in our code. We can. Functionally speaking, it'll run, but it's not really a good idea. Right, so this works, but not really very clean. All right. So there's two types of loops on here. And I'm actually going to jump ahead a little bit on this real quick. So there's a type of loop called a for loop, and a for loop will go over a finite number of times. A while loop will run forever. First, we're going to cover for loops, and we're going to come back to this slide. Okay. So how does this work? So in the event of a for loop, you end up starting the loop. Each time, it does a check to see if it's the last item, right? If it's the last item of the loop, it will end up exiting the loop. So if you somehow executed a loop that had 0 items in it, then it would immediately go through to this condition. However, if you have, say, anything more than 0, you're going to continue to loop through this until you've gone through all the items. So for example, let's say I had a, say I had a list that contained, okay, I'm not going to try and draw that. Let's say I had a list that contained 4 elements with values of 1, 2, 3, and 4, right? In that case, we're going to go through 1, go through 2, go through 3, go through 4, and then exit the loop. Let me show the code for this. So, for example, here we're doing a for loop over a list. So, our list contains 3 strings, which are cat, window, and defense straight, I believe. Okay. So, what will happen is every time this loop executes, it's going to initialize the value of W to contain that respective item. So first execution, W will equal cat. Second execution, W will equal window. Third execution, it will equal defense and straight. So, and each time, this would end up printing that value. Okay. Before we go on to while loops, are there any questions on this?
So,
Go for it.
so I guess the answer, it will just print out every word. So print out cat, window, and defense, or wherever you pronounce it.
Yep, you are correct. Nail right on the head. And it'll end up printing them in order as well. So it's going to go through element by element, right? So, yeah, you've worked in Java previously, so like index 0, index 1, index 2, right? So it's just going to go through the whole, list.
What's the in statement for between the W and words?
So in Python, what the end statement means is we have a list provided on the right side, right? So what this does is this causes W to be initialized with each individual element within words as we iterate through here. It's similar to a, what's the term I'm looking for? Is a for, not a for each.
See it as an, well,
Go for it.
I would just replace it with the word inside. Because you can use in syntax somewhat in other places as well, but as long as you see it as inside, so W is inside words, I think it makes sense.
Yeah, I agree with you on that, yeah. There are some languages that have functions that are very similar to how this behaves, but why is JavaScript the only one that's coming to mind right now? I know there are others. But yeah.
I don't know.
But yeah. Hopefully that answers your question.
Yeah,
Cool.
thank you.
That's awesome. Anytime. All right. So while loops are actually slightly simpler. So a while loop will continue to execute forever until its conditional is broken. And yes, this means if the conditional always evaluates to true, it's going to run forever. Which may or may not be what you want. So, yeah. So going back to, or let's show some code on this real quick. So this is terrible security practice, don't do this, but it's a good example. So we have a value of x equals password, right? Okay. On the first run, x does not equal secret, right? Okay, so we know password does not equal secret. So this loop is going to execute. All right. We then have, as our first line, we have x equals input, please input a password. And that is going to set the value of x up here, right? So let's say I set it to secret. Okay, in that case, let's say I don't set it to secret. My apologies. Let's say I don't set it to secret. It's going to immediately output the text. It's not the right password. Otherwise, it's going to output the value. It's the correct password. And because that condition, in the event it was set to secret, because secret does not equal secret is now false. As a result of this, it would end the execution of this loop. So let me go through that again real quick. So we start off with the value of password for x. And on our initial value, x does not equal secret. Password does not equal secret, which means this loop will continue to execute until the value of x is set to equal secret. Because once you have secret does not equal secret, the evaluation is now false, and you end up with the condition of while false, which means the loop will end. X input would set the value to, x equals input would set the value of this to change it. And x does not equal secret is the text we're going to output every time the user provides us the wrong password. Does that make sense? Go for it.
Again, do we need the while statement there? Because I guess, like...
It is somewhat of a redundant example, to be honest with you. Yeah, it's somewhat of a redundant example. So this is more to, the reason that we're using while here is to force this input condition to re-execute. You could do the same thing by having this all in a function and calling that function again when the user inputs the wrong password. That's also an option. Another option you could take. Yep. Yeah, this is I'll admit somewhat of a roundabout example, but it's a way to show a while loop, right? Another option on this is there is a keyword called break. So we could also have a condition in here where if we say, for example, had x equals secret break, it would immediately exit out of the loop. Yeah, and that's a lot more common pattern in, you know, a production setting, right? Whenever you're actually writing while loops, because this is slightly more hard to read.
So basically, the while loop is there, so it will if you don't put the password in right, it will recall the while loop, go back to the while.
Exactly. It will continue. Exactly. It will continue to execute this until the value changes, or until you set the value to equal secret.
Cheers.
Yeah. All right. That's a tricky one. All right. I'm going to jump to the next slide real quick. So there's some merits to this, right? So, because the thing is, you can use either of these in a lot of situations. It doesn't necessarily mean one is going to be recommended. Well, it doesn't necessarily mean one is going to be a better decision than. In most scenarios, you could use a for or a while. It does not necessarily mean that it's going to be. There are scenarios where one makes more sense than the other. So, for example, for a for loop, if you know beforehand how many times the loop is going to run, that is very much a preferred solution. Or if you are just going to be stepping through a list and you know the list is a finite number of elements. For a while loop, if you don't know how long the loop needs to run, but you know it needs to end eventually, it's a good example for it, or a good use case for it. A common example of this is if the program needs to run forever. So, for example, a video game is a good example. Another one could be, say, an operating system, something that just needs to stay running for however long until you no longer need it. So, until the condition has changed and you can close it out. To be clear, there's nothing stopping you from using a while loop in the same syntax as a for loop. It's just going to be slightly more difficult. All right. Okay. So we got a question slide here, and yeah, okay, we got a question slide here, and this is actually the last question slide before we do the workshop, before the workshop piece, but before we talk about the workshop for this week. So does anyone have any questions on what's covered so far? Go for it.
Where can we find these slides? Because I had a bit of trouble concentrating, and I would like to look over them again. Would there be a place I can find them?
They should be on the resources page that I want to say we have linked in the Discord currently. If we don't, I will make sure it is linked after this.
Thank you.
Anytime. Let's see, enter to CS. I will make sure that is linked. All right. So what we did last time is we had a announcement that was made. Yeah, I'll just post that announcement. So similar to what we did for week 1 and 2, there'll be an announcement made that includes the slides. All right. All right. So that's actually all I've got on this. A little bit less filled than last week, but yeah.
Can you just go through the slides again, I guess?
We can,
I
yeah.
might have missed some.
Yeah, absolutely. We can just scroll through these real quick. Was there a specific area you wanted to see?
What was the explanation? Exclamation mark equals.
That does not equal. So, in the
Okay,
event
yeah,
of
I was thinking that. Sorry.
yeah, exactly. So, for example, like A has been set to green, and we do A does not equal red, right? Which would return false.
Hmm. Okay. Why is 0.99 less than 1 is true?
I mean, it technically is less than, correct?
Okay.
So, yeah. So,
Is it just a point in there so it can be act as not as an int but as decimal
so
decimal
right.
places?
So in this case, it's more of a 0 0.99, right, is less than 1, right? So
Mm.
if we had, so like let's say for example this was 0.9, right? If this was 0.9, it would also be less than 1, right? In this case, demonstrating this more to show that the value is less than, we could achieve the same result with this being a value of 4 and this being a value of 3, and it would still return the less than on this.
Okay.
Yeah. On the same token, 1 is greater than 1 is not true, right? Because 1 equals 1, right? So in that case, that one would be false. While greater than or equal would be true. All right. I went through this a bit with demonstrating that the x value, so like let's say for example, x is less than 0, right? So if x is less than 0, actually let's just go through all these real quick. So in the event, let's say x is -1 divided by the user input, right? In that case, we are going to end up with receiving the text negative change to 0, right? Let's say we pass this in as 0. Okay. In this case, x equals 0, we'll end up printing 0. In the event we got 1 from here, it will end up printing 1. And in the event we got a value that was greater than 1, we're going to fall all the way through to the else condition here. So the way this reads is if condition, then do this. Elif is else if condition. So in the event the if condition or else if condition above us is false, then perform this check. If this check is true, then execute this code. In the event that all of the above ifs and elifs have been false, then execute the else block. All right. Are there any questions on this? I know we're going back through the slides a second time, but are there any questions on this part?
So if you typed into the answer, it would just print more?
So what are you asking? So if in here, if I typed in a string?
Yeah, if it says please enter here and you entered 2, it would just go to the else statement where it would just say more instead.
Yep, correct. Nail right on the head. Yep, exactly. In some languages, this is also read as else if, as opposed to elif. Yeah, I actually misspoke when I was saying it earlier and treated them interchangeably. I mean, functionally they're the same thing, but elif is what's used in Python. Let me go back through here real quick. let's go back through this real quick. So the way this goes is we would find the list on the right-hand side of this, of the in, and on the left side we would find the variable that will be initialized / populated with the value each time it goes through the loop. So in this case, first iteration, W is going to be cat. Second iteration, W is going to be window. Third iteration, and I'm going to stop trying to pronounce this. Yeah. And by all means, if there are any questions at any point, please stop me. Ah. Correct. Yep. Python depends on indentation for what you would typically use curly braces for in most other languages. It's somewhat of a controversial topic among some people, but yeah, that's how they handle it. True. Yes, it can be a little strange on that. Let me flip through to here. All right. So we did go through this example a little bit earlier, but for x equals password, right? So we have password is the original value for x, which is going to be password does not equal secret. So this is going to evaluate to true, which means the loop is going to continue for the first execution. We then provide a value to x, which will be set to that. We then do a check that if x does not equal secret, which is the password we are currently checking for, then it'll print it's not the right password. Otherwise, with else here, it'll print it is the correct password. And once we've gone through this loop iteration, we then do the check again, and at that point we will see that x has been set to, in the event we put in the right password, x has been set to secret. So secret does not equal false is false, and the loop execution ends. Went through this a little bit. Okay. So are there any questions on this material? Okay. Are there any questions in general with Python or any problems anyone has had while going through worksheets or going through working on their own that they would like to ask? Or are there any questions in just... All right. Okay. Ah, well, if I don't have anything else to cover and there's no questions to answer, maybe we should call it. Call it a short one this week. We could talk the worksheet. It would probably not be ideal to go through it within VR. But if anyone has any questions on, last week's worksheet and whatnot, we can answer them by all means. All right. Well, have a good one, everyone. Take care. See you all on the worksheet. Not worksheet. See you all in the workshop on Friday, and Apple's lesson is on Wednesday if anyone wants a second perspective.
Thank you.
Yep. Have a good one. Take care.